Hello there, welcome to section 6 of Unit 1. And in this section, we'll be looking at Newton's laws of motion. Let's look at the objectives of this section. The first objective is to state Newton's laws of motion, explain the laws of motion, and solve some related problems in relation with the law. Let's look at Newton's first law, and it is also known as the law of inertia. And it states, every body or object remains in a state of uniform motion or in a straight line unless it is compelled to change its state by other external force. So let's say we put a rock or a box on the ground and there's no external force acting on it. It will always be there stationary and nothing will turn it to move. But supposing that we use an external force to act on one side of it, meaning it's going to change its state and move away from its constant velocity. And also, supposing that two people act on it oppositely, meaning it was going to stay at rest. It's like playing a ball on a football pitch. Anytime a ball is on its state or it stays at rest unless an external force acts on it, which is going to change the direction or the motion of it. It will continue to move in a straight line at a constant velocity till another external force also turns it to a rest. And that is Newton's first law of motion. Inertia and mass. Let's look at this relative example here. Should in case we have two trolleys, one is empty and one full of goods, which one are we going to need more net force to push it or to pull it? The inertia of an object is quantitatively measured by its mass. So we say that mass is therefore the property of an object that specifies how much inertia the object has. Meaning that the greater the mass of an object, the less that object accelerates as a force is applied on it. And we are going to look at a relative mathematical expression in the next slide. So we define inertia as the natural tendency of an object to remain at rest, or if its motion has a constant velocity along a straight line. And we say that mass is an object of a quantitative measure of inertia. Mass is an inherent property of an object and it is dependent on the object and it's independent on the object's surroundings. So we say that mass is a scalar quantity, and I hope you know that in our previous sections. Newton's second law of motion. The Newton's second law of motion explains the force, that's the net force, and the acceleration, and relates them when they are acted upon a mass. So Newton's second law of motion states that when the net force acts on an object of mass, say m, the acceleration that results is directly proportional to the net force and inversely proportional to the mass. And mathematically, we write it as A is equal to the summation of the net forces over m, where m is our mass, A is our acceleration, and F is is our force. We can also represent it by the summation of the mass of the force equals ma, and its unit is either newtons or kilogram meter per second squared. So let's do a relation here. In case we have a mass m1 and we have a mass m2 where m2 is greater than m1, it means that we need more force on m2 than m1 to get the same constant acceleration. Let's look at the last law of Newton. That's Newton's third law of motion. And it states, whenever one body exerts a force on the second body, the second body exerts an oppositely directed force of equal magnitude on that first body. That is, to every action there is equal and opposite reaction. So in case we are swimming in a pool, you need an external force to bring you forward. And let's say a rocket moving out of the space, it needs a hot gas to push it up. Let's say a gun. Before the bullet comes out, it recoils back.